Okay, so this is Chapter 1, Section 7 for IM2, and this is solving an equation in the form ax squared plus bx plus c equals 0. So now we're going to have a number coefficient out in front. So like I said in the last video, it changes just a little bit, but we still kind of go through the same idea here. So as we're looking at these numbers, let's go ahead and read this notes part up at the top here. So prime polynomials, a polynomial that cannot be written as a product of two polynomials with integral coefficients. So the main idea here is that we can't factor anything out. Nothing can multiply to get that end term and add to get the middle term. So it's just one of those situations. So when we're looking at this case, because now we have an a here. We didn't have an a before, but now we do. We're going to have a coefficient here. We apply the pattern of factoring by grouping to write the desired form. And in this case, what they want us to do, and I'll kind of explain this a little bit more when we actually go down to the next one, they're going to have us kind of separate it out so that there's the idea of factoring by grouping. So we find two numbers that have a product of A times C, or AC, and a sum of B. So we're still looking for the product, but now we're looking for a product of these two terms together, and then a sum of B. All right, so we're going to use grouping to find the factors in step 3. So let's go ahead and take a look at this one so I can actually show you kind of what this means. So we want two numbers that will multiply to get A times C. So 2 times 10 gives us 20. So we want to multiply to get 20, and we want them to add to 9. So what we want to do is we want to look at the factors of 20. 1 and 20, 2 and 10. We can't do 3, but we can do 4 and 5. So whoop, I found it. Those two add up to 9. So that's the idea here, is we want 4 and 5. So when I rewrite this, I'm going to have x squared, and I'm just going to break this apart. So I'm going to have 4x plus 5x. Instead of 9x, I broke it into 4 and 5. And then plus 10. So now we can group these. So we have two groups, just like we did when we were factoring by grouping before. We have 4 terms, so now we can group and factor. So I can look at these two terms, and I can, 2x squared has 2, and it has x and x. 4x has 2 times x. So I have 2, and I have an x, right? So that's my greatest common factor is 2x. I'm left with just an x on that first one, and I'm left with just a 2 on that second one. Plus, with this one, the only thing in common, the only thing I can divide away from both would be 5. So you can write out the factors again, but I can see pretty quickly I can only divide that by 5. So 5x divided by 5 is just x. 10 divided by 5 is 2. So now I have my identical binomial. And I'm going to take my two multipliers here, and I'm going to put them together. So I have 2x plus 5. There's my first binomial. And then the second one is x plus 2. So again, remember, this is going backwards from one of those very first methods we learned for multiplying binomials. So again, you may want to go back and take a look at those just to make sure you remember how we did that method. And I believe that was in section 2. So now I can say equals 0, and I can solve this problem. It doesn't actually look like they make us go that far for this one. They're going to make us do that on the second one here, since they didn't say equals 0 on here. So we're done with this guy. This is the answer that they want. We factored it. All right, let me scooch down here so we can do the second problem. Boop, 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 boop. All right, so here's our second practice problem. So we want a factor that will multiply to a times c, so 6. And then we also want it to, and in this case we want to make sure it's -3, so -6. And then we also want it to add up to 5. So if I look at this, I have 1 and 6, and I have 2 and 3. We want one of them to be negative so that we get the -6 here. And then because it's a positive 5, I also know that I want it to, the bigger number to be positive. We need to make sure that we have it in the correct order here, because that does start to get a little bit more complicated. Although factoring by grouping does help with this a little bit, as far as knowing the right placement. So the only ones that would add up, or in this case subtract to 5 correctly, would be 1 and 6. And actually 2 and 3 will add up to 5, but we want them to subtract because it's a -6. So just be careful about that. You know, since it's 2 times -3, it's -6, not +6. So one of them is going to be negative. All right, so we're going to go ahead and write this out. So we have plus, and instead of 5x, I'm going to break it apart. And it's going to be 1 and 6. And in this case, I'm going to make it +6x and -1x, like that. So I'm going to do plus -1 like that. Nope, not plus. Haha. -3 equals 0. All right, so now I can group them, and I'm going to use brackets here to group them like that. And in this one, again, you can write the factors out like I did over here on that first one, or you can look at it and say they can both be divided by 2. And I can take an x out of each. I can only take one x out of this one, so I can, that's what's going to go in the front here. So if I divide by 2, I end up with 1. I don't have to write the 1, but if I divide by x, remember there's 2 of them here, so I have 1 left over. Plus, if I divide by 2, that's 3. If I divide by x, well, x divided by x, or any number divided by itself, is 1, so I'm just left with 3. Plus, all right, so in this case, there's the only thing that we can take out, and we actually want to pay attention. So this is x plus 3, and this is -x minus 3. So they're identical to each other, except for the positives and the negatives, right? So they're called additive inverses. So if we divide the -1 away, and I'm going to put -1 on the front here, so I'll actually change. Come on, go back. I'm going to change this to negative instead, so it's a little less complicated looking. So it's -1 on the front. That's what I'm going to divide away from everything. If I divide -1 out of this, I just have positive x. And if I divide -3 by -1, I have positive 3. So we wanted to do that. Oop, I forgot to put equals 0. Equals 0. And we wanted to do that so we had identical pieces here. So now I have 2x minus 1. That's my first. These are my multipliers, right? So they go back into a binomial together. And then x plus 3, because those are my identical pieces. So in a way, what I'm doing is I'm kind of dividing x plus 3 away from these. And what am I left with? 2x minus 1. So in a way, I'm doing the same thing I did with this 2x in this first piece and the -1 in the second piece. I'm just doing it with a binomial now. So if you kind of think of it that way. So I'm going to uncross those out. So this still equals 0. So I have 2x minus 1 equals 0. X plus 3 equals 0. We're going to go through and solve. So plus 1, 2x. 1 minus 1 cancels. And we'll divide by 2 on both sides. So x, because these cancel down to 1, 2 divided by 2 is 1, equals 1/2. And then for this one, we just simply have to subtract 3. 3 minus 3 cancels, and we have x equals -3. All right, so we have one more page here. I believe there's 3 problems on this page. And we will be done with section 7 here. So factor the polynomial. If the polynomial can be factored using integers, if it cannot be factored using integers, write prime. All right, so remember, we want it to multiply to get a times c. So 2 times 24 is 48. So these are the factors we're looking for. 24, 20, darn it. It's a really ugly looking 24. I don't know why that's so ugly looking there. Come on, go back. There we go. My pen tool started messing up on me here. 48 divided by 3 is 16. We can divide by 4 and we get 12. We can't divide by 5 because it doesn't end in a 5 or a 0. We can divide by 6 because remember, if it divides by 2 and 3, it can divide by 6. So we get 8. Whoops. We get 8. It can't divide by 7. I just kind of know that one, but if you didn't know that one, you could test it. And then we come back to 8 here. So now we have all of our factors, and they need to add up to 19. In this case, it's positive and positive, so I know they're going to add up to 19. So we want to look through these and find the ones that add up to 19. So there we go. We found them. So I have 2x squared plus, instead of 19, I'm going to break that into 2 pieces here. And I'm going to have plus 24 on the end. So I'm going to have 3 and 16. So now I can group these guys and start factoring. So I can't divide 2 or 3 away because they're both prime, but I can divide x away. And if I divide 1x away from here, remember there's 2, I'm still left with 2 and 1x. If I divide x away here, I'm left with just my 3. Plus, let's see, what can these both divide by? It looks like 8. Can definitely divide 16 by 8 and 24 by 8. That's the biggest number. And again, if you needed to, come over to the side here and list the factors of these numbers, that's perfectly fine. If you don't know off the top of your head what the greatest common factor is, you can write the factors out and figure it out by simply going, it'd be 2 times 8. Well, 8 can break down into 2 and 4. 4 can break down into 2 and 2. And then we have x. We can do the same thing with this one. We can go 2 times 12 gets us that. 12 breaks down into 2 and 6. 6 breaks down into 2 and 3. And we have no x. So now we have 2, 2, and 2. 2 times 2 times 2 gets me 8. So it's just if you're not sure, you can always break down the factors. And since they don't have any x's, there is no other piece of the common factor. It's just 8. So if I divide by 8 here, I have 2x. I meant to do more of a common parenthesis. Plus 24 divided by 8 is 3. So now we have our identical binomial. And we're going to, like I kind of said on the last screen, we're going to kind of factor that out. So if I factor that out, I'm left with x and 8. X plus 8 times 2x plus 3. Remember, when you factor it out, just like I factored out x here, it doesn't disappear. It just, we usually put it on the front, but in this case, the identical one usually is the second one. Let me see. Are we solving this guy? We are not. So we're just stopping here because they don't have equals 0, and they're not asking us to solve. So we're kind of all done. All right, so we're going to factor this one. Again, if it cannot be factored, we just write prime. So we have a and c. 5 times 4 equals 20. So I want to write the factors of this guy. Can't do 3. We can do 4. And then the next one would be 5 and 4. So those are our 3 sets of factors. And we want it to add up to 3. So if I look through here, there are no factors that add up to 3. Doesn't actually mean that there's no solution, but there's no integers that we could use to get 3. So we're going to end up having to use decimals in this case. So because it already told us, if we can't use integers, we just write prime. right, let's do our last one here, moving down. So we're going to do the same thing, 4 and 10. So 40 and 2 and 20. 40 does not divide by 3, but it does divide by 4, right? Does divide by 5 also. It does not divide by 6 because remember I have to divide by both 2 and 3 in order to divide by 6, which is one of those multiplication fun tricks if you know all of them. And then it does not divide by 7, and it does divide by 8. We already know that. So we'd be coming back to, 8 times 5. We don't have to write them twice. So those are our factors, and we want them to add up to 22 because it's plus and plus. I know I'm adding. So the only one I see is 2 and 22. That adds up to 22. So we have 4x squared plus boom, plus boom. Remember, we're breaking 22 into these two pieces. So we're going to have 2x and 22x plus 10. All right, let's make sure. Oh, not 22. Sorry, just 20. I was writing it funny. 22 is the total there, but I wanted it to be 2 and 20. So now we're going to group them. So in this one, I can definitely divide away a 2, and I can divide away 1x because this one only has 1x to divide away. So divide by 2 and I get 2. Divide by x, I still have 1 left over here because remember there's 2 here. If I divide 2x by 2x, it's not 0, it's 1. So be careful about that. I have had students write 0 there on accident. All right, with this one, it looks like only 10 because 20 can divide by 10, 10 can divide by 10, but they don't both have a variable, so I'm going to divide by 10. If I divide 20 by 10, I have 2, and then the x comes down with it. 10 divided by 10 is 1. So yay, we have our identical pieces here. Boom, boom. So now I have 2x plus 10. That came from our multipliers here, 2x and 10. And then the second binomial is the identical one. And again, there is no equals 0 on this one, so we don't have to worry about continuing to solve it. They just wanted us to factor the polynomial. All right, so that was section 7, and I will see you in section 8.